Okay. How do we convert 390 degrees to radians? So what is a radian? A radian is just measuring a measurement system that uses pi. The distance from here to here, around the circumference of a circle, is 1 pi. And if you go full circle, it's another pi, which means the circumference of the whole circle is 2 pi. So that means 1 pi halfway around the circle is worth 180 degrees. 2 pi is worth 360. But knowing this fact, if we're converting 390 degrees to radians, which uses pi, we got to ask how many 180s fit in 390? How many pi? Well, let's find out. 390 divided by 180 is, well, it's this many pi. It's 2.1, and so on and so on. However, you've got to give your answer in simplest form, right? So that means no decimals because it's not going to be accurate. Simplest form generally means fractions. So this is the how many pi. This is how many 180s going to 390. It's that many pi's that will represent the radians of 390. So that means simplifying this fraction, divided by the largest number that can fit into 390, I believe 30 would be that number. So 390 divided by 30, looks like that's going to be 13. 180 divided by 30 is 16. So this many pi. And don't forget to say pi. Oops. Radians to degrees, it's the same process, but backwards. Remember, every pi is worth 180 degrees. So really, if you just replace that pi with 180 and calculate that, that should be the number of degrees we're talking about. $420. For this exercise, you're not going to do calculations. You're going to do some quick math in your head and also visualize some things that have to do with size. Okay. I am going to talk through my answers to these questions, and I'm going to show you kind of like what tricks I use. Well, 360 is just 2 pi. We know that by definition. 120, that can be split up into 3 60-degree slices. 60-degree slices are thirds, and I need 2 of them. 300 can be also divided into 60-degree slices, and those are the big slices. And it looks like 5 can fit it. The 3 tells me that these are the 60-degree slices, which are the thinner or the thicker ones. 90 degrees, that's half a pi, because that's halfway around the circle. 120, yeah, again, it's the 60-degree slices, which are thirds. 45, these are what I call the quarter slices. And so 1/4. Now, let me kind of show you what I was talking about. Okay. What we talked about is this is 1 pi. Okay. This, by the way, is a radius of 1. And if I go all the way across the circle, I've gone 3.14 units, and so on. Approximately 3.41 units, if this is 1 unit. So that's how I justify that pi length from here to here. And that's equivalent to 180. Okay? So what I was talking about, quarter pies, here's a quarter pi, here's another quarter, here's another quarter pi, here's another. 45, 45, 45, 45. So 45 is associated with a quarter pi. I split up my pie into four slices. The what I call the thin slices, there's 6 of them. And given that there's 1, 2, 3, 4, 5, 6 of them, they're each worth 30 degrees. This is 30 degrees. And like I said, it cuts a pi, which is half a circle, into sixths. Okay? So these are called thin. Just to give them names, I call these quarter size. Now let me talk about the thick slices. The thick slices are 2 30-degree slices. Okay, so it's 60 degrees, and there are 3 of them per pie. 1, 2, 3. So that's why they're 60 degrees, because they're fatter. But 60 degrees is 1/3 pie, and these again I call the thick slices. There's the half slices too, which are 90 degrees. Right? That's 2 quarter slices, but that's, you can tell that's half. 90 is pi over 2, which means these are the half slices. Okay, so you get your half, you get your quarter, you got your, what I call thin and thick. 30 degrees, which is, pretty thin kind of slice of the pie, so to speak. So let's go back and see if we can do some more of these. 40, okay, let me start over. 315, that's interesting. So 315, my little tip is if there's a 5 at the end, it's going to be one of the quarter slices. 360 is here. Minus 45 puts us right here. So since we're talking about quarter slices, it's going to be this answer. But look, it took 7 to get to here. 7 quarters. 1, 2, 3, 4 quarters, 5 quarters, 6 quarters, 7 quarters. 1 shy of 8, because 8 quarters is all the way around. So 7 quarter pi is definitely our answer here. $2.70, well, that's 3 half slices, right? 90, another 90, another 90, 270. So half slices, looking for a denominator of 2, there it is, and there are 3 of them to get to 270. I'll do one more. 225, that's a good one. 225, it's more than 180. And how much more? Again, that 5 digit is a giveaway. It's 45 more than 180. So you're right here. 45s are these quarter slices. How many of them are there? 1. Well, it takes 4 to get to here, and it takes 1 more to get to this spot right there. So it's 5 quarters. Okay? This is the same exercise, except you're going backwards. 11/6. So the translation here is sixths mean 30 degrees each sixth. I want 11 of them. So that's 330 degrees. Right here. Quarter slices. Quarter slices. And up top, we're only talking about one. Each quarter slice is worth 45 degrees. Seven slices of sixths. Sixths. These are the thin 30-degree slices. And I've got 7 of them. Where's my 210? There it is. I'll do one more. Oops. 11 of the thin slices. Okay. These are worth 30 because they're thin, 30 degrees. So we're going to look for 330. Okay. I'm looking for, we haven't seen one with a denominator of 3, the 1/3 slices, which are worth 60 each. But that's 180 plus 45. That's 30. Okay. Anyways, let's start again. Oh, there we go. Well, that the 1/3 slices are worth 30 each. No, 60. Sorry, 1/3 of a pie, 60, because they're thicker. 60 is just a thicker slice. Okay. Here, you're just combining your knowledge now. Instead of giving you degrees to find your way in the inner circle, you're given radians. So here's a sixth, here's 2/6, 3/6, 4, 5, 6/6. So 7/6 ends you right here. It's a radian measure, 7/6. You need the sine of this. The sine is the distance to the x-axis, the linear distance, otherwise known as opposite. Okay, but this is associated with, because sine is affiliated with y, you are definitely going to have a negative number. Now, when you're inside the quadrant, there are 1, 2, 3 stops inside the quadrant that are your common angles. And what I suggest is that you do literally memorize the 3 values for each trig function, and they're the same for all 3. For each trig function is what I meant. You have a small number, you have a medium-sized number, and then you have a long, or small, medium, and large size number. Okay. For this angle right here, you're looking at the small, which is 1/2. Okay. When you're at the 45-degree angle, and I'm using the reference angle. When you're at the 45-degree angle, the length is medium. I call that medium. And then for this angle, which would be 60 degrees from here, I'm talking about the reference angle. You're using the long length, which is √3/2. There are really 3 values. Okay. And then for sine, you're still going to have 3 different lengths. For cosine is what I meant, cosine. So cosine of this angle here is the long length. Cosine is horizontal. It's affiliated with x. So that length there is large. And then this, when you're at 45, is the medium length. Running out of colors. Medium length. And then this is the short length. The short length, which is the adjacent side, the short length. Okay? So they will still correspond to these three numbers. So memorize small, medium, large, and that these are the values for small, medium, and large, and I'll talk through this. So right here, sine, small length, and it's negative. Got to do a two-stepper. Negative 1 half. Cosine of pi over 3. 1/3 pi. Let's go 1/3 around the circle. That's a sixth around the circle. That's a third. It's the this length right here. It's also the smaller of the three, the smallest of the three lengths. And because it's on this side of the y-axis and it's about the x, it's positive 1/2. Tan. Now let's talk about tan for a sec. Let's first go to the correct angle. 1, 2, 3/3. Right here, we've arrived at 3/3. Okay, another third of the way around the circle, that's 2/6. But another third, that's the 5th third that I've just traveled. So we end up right here. Now, sine, you have to kind of give it another definition when we're in the unit circle. Tan, is sine over cosine. Okay, sine over cosine. So what's the sine of this angle? It's this. That's sine. And then what is cosine of this angle? It's this. So notice, given if we use our labels from before, it's tan of this location, that location right there, is the long over the short. The long length over the short length. Right? By the way, the sine will be negative because of what quadrant we're in. This is a negative value, that's a positive value. But it's long over short. Now, long over short, as a fraction, will be greater than 1. Anything that's bigger over small, medium, large, long, large, over something that's small is going to produce something that's greater than 1. Let's do another example of an angle. Let's take this angle right here, which is a 45 or a quarter angle, quarter pi from here. The sine and the cosine are exactly the same. This is root 2 over 2, negative. That's root 2 over 2, also negative. These are exactly the same. So when you have medium, that medium length over the medium length, the tan will be 1. Okay? And then lastly, last example, if you are, let's say, here, that's 30 degrees. This is actually angle 150, otherwise known as 5/6. Right here. Let's look at the two lengths that we're supposed to compare. They're going to be the sine over cosine. And that is the short length over the long length. Whenever you have something smaller over something larger, that's less than 1. Okay? Here are the values, the actual 3 values that you should memorize that correspond to greater than 1, 1, well, 1 is just 1. Greater than 1 is root 3. Less than 1, root 3 over 3. By the way, what is root 3? Put it in your calculator. It's 1.71, et cetera, et cetera. So this is larger than 1. So when it stands alone, that's a value that's greater than 1. When you put 1.7 over a 3, that's going to be less than 1. So look, not too hard to memorize. Root 3, 1, root 3 over 3. But the important thing to keep in mind is the size. Okay, so let's go back to this. We are here talking about sine over cosine. Long over short, greater than 1. This is the one that goes root 3. And it's negative because this value is negative, this value is positive. Negative. Okay, now you don't get the circle tool, you just have to make up your own tool. 3 pi over 2. So these are halves, so let's travel by halves. 1 half, 2 halves, 3 halves, right here. What is sine of this value here? This is one of the ones where you have to associate sine with y. And remember, the x value of this is 0 if it's a point on the, if it's a point on a coordinate plane, but the y value is negative 1. So y is going to be negative 1 here. Okay? This gives you, I don't know if this is helpful. I don't recommend trying to memorize that chart, but memorize the principles or the concepts behind what we're doing here. Exact value of tan of pi. Okay, so let's locate ourselves first. Where is pi? That's kind of an easy one if you just know the fact that this way around the circle, half a trip around the circle lands you at pi. What is the tan of this? Tan is sine over cosine, which is equivalent to saying it's the y value of that point versus over the x. The y value of this is 0. The x value of this is negative 1. So y is 0, x is negative 1. Oops, sorry. That value, 0 over negative 1, is 0. It's fine to have 0 in the numerator in the top. It's not fine, so to speak, when it's in the denominator. 0 in the numerator, answer is 0. 0 in the denominator, undefined. I don't know if we're going to have one of those. Well, let's continue. 3 pi over 2. Okay, so look at the denominator first. So you know your denomination that you're using. You are going by travel by halves. Here's 1 half, here's 2 halves, here's 3 halves. We're right there. What's the value of cosine right here? Cosine is x. That point is 0, comma, negative 1. So therefore, cosine of that angle or location on the unit circle is 0. 2 more. Now we're in the reciprocals. Cosine of pi over 3. Cosecant. So cosecant of pi over 3. Where is pi over 3? Well, these are thirds. So we're traveling by thirds. And that puts us kind of here. It's kind of close to the, closer to there than it is to here. Let's put it that way. This is 1/3, which is the same as 60 degrees. But the main thing is when we define cosecant, it's 1 over sine. Therefore, your first job is to find out what is the sine. Then you flip over that value. What is the sine of this? It is the long. Among the three, that's the long, not the medium, not the short, that's the long. And the long, if you remember, is root 3 over 2. Okay? This is sine. Now, if we were asked about cosecant, which is flip over the sine, we got to flip this over. 2 over root 3. But we're not allowed to put a radical in the denominator, so we rationalize this way. And this multiplies to 3, and the top is where the radical ends up. Okay? So your answer, as strange as it is, 2 root 3 over 3. Now, the last thing that you should check, we are talking about the reciprocal of sine, and this is in quadrant 1, which means we're talking about a y value that is positive. Okay? Got to worry about two things now, not just the numeric value, but the sign, S-I-G-N. 2 root 3 over 3. Okay. A couple more left. Secant. Let's do another reciprocal. Okay. Secant is defined as 1 over cos. Remember, the C and the S kind of switch. Got to flip over cosine. All right, well, let's find out cosine first, and then we'll flip it over. But let's find out where we are. 5/3, 5/3. So let's go 3/3 all the way around. 1, 2, 3/3, 4/3, 5/3. This is where we landed. So this is the one that's a little closer to here. So cosine, I'm eyeballing kind of how far this is from here, these two lengths. That's the short one. Because it'd be longer if it was here, it would be longer still if it was there. This is the short. So that short length is 1/2. Okay? That's for cosine. Cosine is 1/2. So guess what? Secant of the same spot is this flipped over. Oh, that's easy. 2. Flip over 1/2 and you get a 2. Oh, almost forgot. What about the sign? Is it positive? Positive or negative? It's positive because of the location of that angle. Positive 2. Wait, I'm sorry. It's not advancing us to... Maybe I put too many to do in there in that one particular one. Anyways, we got some good practice on that. So this is going to be test how well you remember this stuff. This, in terms of speed, I think these are all in quadrant 1 for the speed test. Tan of pi over 6, it's short over long. That is less than 1. Cosine of pi over 6, that was the same location, wasn't it? That's the long length of the 3, so that is root 3 over 2. Pi over 4, that's right in the middle of the quadrant. Right in the middle. So that's our medium length, root 2 over 2. Okay, so this is going to quadrantal. Quadrantal, I think before I called these the compass angles, which are these 4. And so this is really, really translating x. Cosine is x. And once you fix your location, x is 1 here. Sine of 0 Sine of 0 is 0. Tan, I wanted to do a tan. Tan of 3 pi over 2. So where is 3 pi over 2? Using this denominator, half, half, last half, right here. Tan, this one you have to think about both x and y, and particularly y over x. Y here, -1. X of here, 0. Uh-oh, 0 in the denominator. Undefined. Okay. Okay, and then this is just a very simple kind of exercise in doing fractions. I'm going to do this real quick. To plot, you're going to see which is larger. It's obvious which is larger, but just indulge delta math. 4, 9 on the plot. How many pieces? You want 9 pieces to break this into. Here's 4/9, right? And this is, oops, 5/9. Oops. Oh, I'm sorry, I can't even read. It's comparing these two. 3/9. 4/9 is greater than 3/9 because 4 is greater than 3. The two fractions have the same denominators. You can compare two fractions when they have the same denominator. That's the whole point. Okay. But when they don't have the same denominator, make it have the same denominator, right? This is a number that 10 goes into. It's a number that 3 goes into. The smallest that you can find is best. The smallest, the least common, I don't know if you call that the least common denominator. It's the number that they both, 10 goes into, 3 goes into. So we broke it into 30 pieces. 30 pieces, 7/10 is like 21/30. Right? I mean, it even confirms that for you. It's so helpful. And then 2/3 is the same as 20/30. Okay, is clearly greater than, because that's that, and this is this. All right. Okay, that should be it.